Hello guys, welcome to the channel. I hope you all guys are fine and doing great. Today we are going to discuss this time taken to mark all node problem of Leetcode. Okay, so I participate in Leetcode Biweekly contest 136 and able to solve all the 4 problems and got ranking 145. Okay, I have already made a tutorial of this third problem. You can check out this on my channel, and this is the tutorial for time taken to mark all node means problem 4. Now guys, for this problem, what we are basically given a directed tree with n nodes. Nodes are numbering from 0 to n minus 1, basic tree definition, and then given a 2D array edges of size n minus 1, where edge is ui comma vi, means there is a edge between ui and vi in the tree. Okay guys, so now what we are given, initially all nodes are unmarked. Okay, now for and we are given two conditions here. If my ith node is odd, it will get marked if any of its neighbor is already marked at time x minus 1. Basically, it in simple language I can say, if this is the neighbor or the adjacent node of my node I, and this is already marked at time x, then my node I will gonna mark at time x plus 1. Basically, if it is odd, it will gonna mark at time x plus 2 if it is even. Basically, this is already marked, so it's node, this ith node will gonna mark at time x plus 1 if this is odd, x plus 2 if this is even. Okay, if this is means, if you can check here, at least one node adjacent to it mark at x minus 1, it will gonna mark at x. So instead of x minus 1 x, I am taking x and x plus 1. Okay, similarly here you can see this. Now guys, basic thing is, this node should be the parent of my ith node, because which node will be the first node in a neighbor of my ith node that will gonna mark, obviously its parent, because I is I we will reach I from its parent, so its parent will mark first of all, then we will mark I. So this adjacent node will be its parent. Okay guys, now I need to find times I. Now what is time I? Times I is the value of time from in at which my all nodes will mark if I am starting at ith node. What does it mean? Suppose I am n nodes, then time of 0 will be the time when all the nodes will be marked if we are starting from node 0. Time of 1 will be the minimum time when all my nodes will be marked if we are starting from node 1. Like, we are changing the starting node from 0 to n minus 1, and we will need to find out what time, how much time we will take if we change the starting node. Okay, all time are independent, that's a basic thing. Now guys, for this problem, what I will use, I use dp on trees. If you don't have any idea, I will refer you guys should watch one tutorial on how we solve DP on trees. This is completely DP on trees, but if you don't have any idea, I will gonna explain you complete solution using DP of trees, so don't worry about it. Now guys, let's break down the problem in simple steps. As always, as suppose this is my tree. Now I suppose this is my child 0. So first of all, what I will do, I will calculate, uh, th this is the tree given to me in problem. Okay guys, all the values, everything. So first of all, I will gonna calculate the value of time I need if I am starting from node 0. If I am starting from node 0, suppose this. Okay, if node 0, let me change the color. If I am changing from starting from node 0. Now guys, suppose here we are taken x time. Now x is the time. Okay, not x, we will find out two times, x comma y, or instead of x comma y we can call it max 1 comma max 2. Now what is max 2, what is max 1? Sorry guys, I have some cough, like I'm not completely fit, that's why, so please don't mind all this. So what is this max 1 and max 2? This max 1 and max 2 for any node, for any node, this max 1 and max 2 is the top to time taken if we are at this particular node. If we are at this particular node, like what I can say, see what I can say, if suppose this is 1, this is 2. So for this, if for this the time taken to cover this particular child will be 1, because suppose we are at time x here. So at time x plus 1, this node will be marked because it is odd. At time x plus 2, this node will be marked x plus 2. Now, now, now see, for this particular node, how much time it will take to mark this particular node? Only one, because x is the previous time already taken. For this, if we start from this particular node, how much time this particular node will take to? Suppose we have, okay, so let me explain you with the example. Suppose it is 2, it is 1, it is 3, it is, suppose it is 5, 6, it is 5, 7, 9. For this particular node, what, okay, for this particular node we will have three values. What three values we will have? Time to cover this particular children, time to cover this particular children, how much time it will take? 2, then 2, or 2. From here it will gonna paint after 2 time, it will gonna paint after 2 time from this. So 2 plus 2, total 4 time. This is odd, I will take only 1 time. 1 1 1, both all three are odd, so I will take 3 time maximum. So what are the top 2 times? I will take 4 comma 3. So if we are at this particular node, I will gonna take 4 comma 3 are the two maximum time that I will gonna take. I will take 1 time as well, but I will not consider it. I need only 2. Why I need only 2? I will gonna explain. I will explain this. For now, this is my DP. Suppose this is node I. So my DP I comma 0 will be 4, means the first maximum value. DP I comma 2 means the second maximum value will be 3. Okay, this I will calculate for all the nodes. Okay, I will easily calculate it. Now guys, I know final this max one for my node 0 will be my answer of, will be my time of 0. Will be my time of, what is the time of 0? Will be the time of 0. Now, what is the time of 0? Time of 0 is the time taken if we are starting from node 0. So what is the maximum time? This is the, I will note, I will color, I will mark all the node in time mx1. mx1 on dp 0 comma 0, you can say anything. Now guys, now the main thing is now dp on trees. Now let's understand how to implement dp on trees. dp on trees, the most important topic. See guys, this particular parent node I have currently, this is my child node. This is current, this is I. Now I have some more child of this, I have some more child of this. Now what I need to make in dp of tree, I will convert this tree into this tree. This will be my I, these two child of I remain as it is. I will make this current child of I will make this current child of I. Now how it is possible? So I will take some number of steps. So first step is to break them down. How break them down? This is my dp of I, separate tree. I need to remove this particular edge. Remove this particular edge. Remove this. Then I need to add this current as my children of t. These two steps. Now guys, now how to break this? How to break this? Now basically, so for each I what we were storing, the maximum 2 time taken. The maximum 2 time taken. So here, when I is child of current, then it may be possible that either dp of current 0 or dp of current 1 is basically due to ith node. Like either of the distance or either of the time taken is because of this particular child node. It is possible. So how to find it? How to find it? Then there are some more conditions. This is my current. This problem is a bit confusing. Okay, bit complex problem. I also take 30 minutes to think and implement it. Okay guys, so this is, suppose at I, my dp of I0 is the maximum for my 0. So if I will gonna uh, I will gonna return this, I will return only maximum value, not dpi1. Why I will return the second maximum value? When I know from each edge I can return only one single value, only once. Like if this is my tree, this is 2 1 3, this is 2 4 6. So for this particular node, my first maximum will be 1 and 1 2. My second maximum will be my one maximum will be 2 and second will be 2 to 4. So basically I have two maximum. DP of this node will be 4 comma 2, means the 0th value will be 4, first value will be 2. Okay, for this particular node, for this particular node. So what I will return to its parent? Only 4 when I am calculating this, when I am calculating this, when I am calculating this, when I am calculating this. Okay, this basically dp of 0. When I am doing dfs from 0, I will only return the maximum one. Why I will return 2? Because I can only return the maximum, so I should return the maximum value among 4 and 2. Okay, so I will always return dpi 0. Now guys, so how it will gonna affect with dpi 0? So dpi 0 is basically the time taken by any of its children. Now for current how, oh, this is my current. Now look carefully, look carefully. I need to find out whether there is any value among my dp car 0, dp car 1 that is from this particular instant of child. Now its maximum value is dpi 0, means I have written dpi 0 from here. Now if my odd is 1, if my I is 1, sorry, if my I is 1, then at current what is the final value that we will return from there? What will be the final value we will return from here is dpi 0 plus 1, because dpi 0 is the time taken by its children, plus 1 is the time taken by it, because this is a children of current. So if I am reaching current, I am marking current as time x, I will mark I as time x plus 1. So because of x, because of I node, I will have only plus 1 time more, only plus 1 time more. This dpi 0 is because of its children. If my I is even, I will need to add plus 2, I will need to add plus 2. Okay, so I can find out child max, child value. Basically child value is the dp I0 plus either 1 or 2, depend on if I is odd or I is even. Okay guys, now if this child maximum value, if this child maximum value is either dp current 0, if either dp current 0 or either dp current 0, then it means I am getting either of those value from my child. Now guys, what basically I need to do, I have separate. Now this is my I node, this is my child node. I am basically inserting this current node to my ith node. So what I basically need, I need to find out what is the maximum time taken because of this child. What is the maximum time taken? What is the maximum time taken? So if this particular value I am getting because of this particular ith node, can I add this? Can I add this? No, I cannot, because if this is the value current 0, like basically let take some example. This value, this is my current node, this is my ith node, name it 1, name it 1, and I have child node 2, and I have a node here with value 4. So my dp current 0, I will have, okay, so for this I don't have any children, so I will have both values 0 comma 0. Now first value is dp I0, dp I1. dp I is basically the node value. Here I will have 2 comma 0. I have only single node, so I will have 2 is the time taken by its children. Now here I will have 3 comma 2. 2 is the time taken by to mark this 4. 3 is the time taken to mark this particular 1 and 2. 1 time taken because of this, 2 time taken because of this, total 3 comma 2. Now when I will try to make this current a child of my I, this this is 1. Suppose this is 5. I will try to make this 5. This is current child of my code. So what is the length of, what is the time taken by this, maximum time taken by this? Either I can have 3, either I can have 2, but can I add them? No, I can. I basically have 3. I basically, so at my current I have maximum time taken is 3, but can I tell that from, if we make child, if we make this current as my child of my I, then I will have maximum time taken as 3? No. Why? Because this 3, this current is getting is 3 because of this particular child only. So this is the reason why my child values, why my current values, c is, let me write it current, just c is child. Okay, because this particular node is the reason why my this current node or parent node have value 3. So what I can say, I will choose the second best, means 2 is the value I can get if I make I make this as a children. So it means I will get 2. So in actually what I will get, I will actually get 3. Why 3? From, if 5 is the child of someone, because initially I was thinking 5 is 0, means at 0 at time, but now 5 will, now 1 is at 0 time, so from 0 time it will take 1 more time, and its children is taking some 2 times, so total 3 time here. If 5 its children, 1 time to 5, 2 time to 4 time, 2 units of time to mark 4, 1 unit of time to mark 5, so it will take total 3. So initially my this is 2 comma 0, so it will become 3 comma 2 now, means I have only 2 as the maximum time, 0 I don't have anything. Now 3 is the maximum time I need if I am starting from 1, 2 is the second maximum time I need if I am starting from 1, for this 3 for this. Okay, I hope you got it. If don't, just make some diagram, because if you are new to DP on trees, it may be confusing to you to understand this particular hard problem, because if this is so simple, only it will not have only 330 solutions. Okay, it will have at least 500 plus. This is not that much simple, because how to manage the time is the main thing here. Okay, so I will prefer to use pen and paper. Please use pen and paper and write the scenario what I am saying, how this will gonna change. Okay guys, so this will gonna change now. But now I have changed my tree to this. I have changed my tree to this. Now in next iteration, I will make 2 as the parent. This one will become child using the same number of operation, using the same type of operation. Okay guys. Now, and here one more thing. When 1 became the parent, is top 2 value I need to change. Top 2 value I need to change. So after, so when I will revert back to this particular operation, like after traversing 1, I have to traverse child 4 as well. So 5 will become parent again, 1 became child again, 2 became child again, 4 became child. Why this? Because now I have to traverse one more possibility when 5 is the parent. When 5 is the parent. Sorry, when 4 is the parent. When 4 is the parent, 5 is the child. Okay, so all possible. So I need to get back to my original structure and then traverse again for remaining child. Okay guys, so this is the scenario. So now I need to update value 3, then I need to set back value 3. Similarly, I don't need to update value 5 here, because 5 is the child, and I will not gonna update, I will not gonna traverse this. Why? Suppose I have make child 5, now I will again make 5 parent and I will traverse it again. Is, is it beneficial for me? No, because my 5 was already the parent. 5 was already the parent. So I will not make 5 as the parent of 1 again, like I will not gonna traverse. For now, for this particular tree structure, my 2 and 5 are the child of my 1, but I will not gonna traverse 5, because 5 is already traversing a child, means I am making this child the parent of the current this one. So if I will make 5 as the parent of 1, it is just same thing. Okay, so I will not gonna traverse this. Code will gonna make you understand thing better. Here. Okay guys, so this is I used to, I don't want to take any risk for time complexity. Now e dot size is n minus 1, so plus 1. This is the total number of node I will have. I will take a vector array of vector. Then this is I will just make a tree. Now I will take a dp2 y dp I0 will be the maximum time its child will take. dpi1 will be the second maximum time its child will be take. Its child, not I, its child. Okay, so I will traverse a dp. Let me remove this code. Ah, that was the commented code only. So dp initially I am starting from 0 parent. I am thinking -1 like, and v comma dp. Now what is my dfs? Dfs is this maximum one. Initially both of them is 0. Now I am traversing for all the child of current node. If I is equal to parent, I will just continue. Otherwise I will find the maximum child of ith children, maximum time taken by ith children. If I is odd, if I is odd, I know I will take only +1. So I will do mx +1. If I is even, I will know I will take +2 unit of time. I will make its +2. This is mx. So if my mx is greater than my mx1, basically this is my mx1, this is my mx2. This mx1 is greater than or equal to mx2. Now this mx is either mx1 or bigger than this. So what I will do, my mx2 will become mx1, mx1 will become mx. Okay, this is basically like update the number when I need to find two maximum number. Otherwise I know my mx is smaller than my mx1, so I will update mx2 like maximum of all of them, maximum of them. Now at last dp current of 0 max1, dp current 1 will be max2. I will return mx1. Now again come here. I will make a vector of answer of n nodes. Answer of 0 will be dp 0 comma 0. Now I will do dfs. dfs1 will calculate, this is dfs, this is dfs1. It will calculate for all the ith node, okay, by converting child to parent, parent to child. 0 comma -1, 0 is current node, -1 parent, vdp answer is the basic thing. At last I will simply return answer. So net look at db1. Initially I am taken this like a and b are the current maximum 1 and maximum 2 value for my current node. I need to make them same again. Basically I don't, because I am not updating any current, so you don't need to take this. You can remove this part. Okay, because when I was implementing I need them, but when I code it I find out I don't need them actually. Okay, so for all the child node, if this is my parent, I need to continue because I have already traversed this. I don't need to traverse it again. Otherwise, now what is x? X is the amount of time. X is the amount of time my current node, means I is the child node, current is the parent node. I is the child, current is the parent node. Okay, basically what I am saying, this I node, its parent is current node parent is par node. So for I, current is the parent. So deep x is the time taken by ith node that I may have as dp car 0 or dp car 1. So I am taken +1 because if ith node either or, I need one more time. If ith node is even, I need two more time. So if this is even, I will increase by 1. Means I need 2 unit of time. One I have already increased, so I will just increase it by 1 more. Now pair max. Now what is parent max? Parent max is the amount of time that I will got if I am making its children. This how much amount of time I will got? 3 is the parent maximum time I will got when I am making this 5 as children. This 5 are children of my one. 5 was initially parent, but when I am making it parent, when I am making it children, I will got 3 units of time. Okay, so if my x is the maximum node, like if x is the first value, if dp current 0, it means dp current 0 is because of my x value. Okay, so it means I cannot have this particular value as the maximum value like this. Here I know this 3 value I have because of my 1 and 2, because of this one child. When I am making it as my parent, I cannot say you can take 3 is my children, because its children already only contain any value that is 2, because 3 is the value that I got because of this particular child. Okay, so I need to return the second maximum value. That's why I calculate two maximum value. So it means the next maximum value I will go as, or basically you can understand it like this 3 is the value I have because 1 is the child. Now 1 is the parent. So 1 is no more child of 5. So I cannot access this value. Okay. If this x is the first value, means current 0 value is because of any of child. This is no more a child. So I need to check. I need to take second maximum value, because uh, except this, all the remaining nodes will still be child of my file. So second maximum value of its child will be dp carbon, so I will take this. Otherwise I will take the first value, means this value is not because of my current child, so that child because of which I got this particular value is still a child of my current node. I can take this. Okay guys, this. Now, if my current node is even, now when 5 became children, so I will again calculate it. I need to how much time it will take. If this is odd, I will take one more time. If this is even, it will take two more time. If this is odd, I will increase it if by one. If otherwise, I will increase it by two. Now I again update my DP of I, like I became parent, so I need to update it. If my current parent maximum is basically now what is at this stage. Parent maximum is the maximum amount of time I am getting when I am making my current node, means the parent node as my child. When my child node is becoming a, when my current node becoming a child of I, what is the maximum amount of time I can get is my pair underscore mx. Okay, if this value is greater than this, I will do simple thing. 1 will become 0, 0 will become maximum, like same like this, same like this. Okay, same like this. Otherwise I will just update my second value to the maximum of any of them. Now after this I know now my dpi0 will be the maximum value if dpi0 will be the child, if will be the root, will be the final parent. So answer of I, like I is the final parent, is this other, and then I will call a dfs1 again with I is my current node, current is my parent node. Okay, and vdp answer as it is. Okay, you may be confused like why my uh, current is still parent, but this I need to pass out, because when I come at this particular situation, in next iteration this current will be here, so I don't need to traverse this like this. This is 5, this is 1. In next iteration, this is 1, this is 5. So when I find out that there is a child called 5 of my 1, I don't need to traverse it, because I means I don't need to make it parent again. Otherwise we will be stuck in an infinite loop. 5 1 1 5 5 1 1 5 like this. Okay guys. So this is a bit complex thing, I know, but if you are using pen and paper, it is not that much hard. Okay, so this is DP on trees basically. So I hope you understand the solution. If you have any doubt, you can just comment out. I will try my best to explain you. Please subscribe the channel, like the video, and check out my channel for more these type of videos. Thank you for watching this guys. Stay tuned.